So this is a demonstration of the black hole and solar system colliders. I'm going to put them all both into one video, as they both work in a similar manner. So if we open up our simulation and I place a solar system in the middle, so you can see how everything moves around. But then if I go into here, I have some sliders here. And what these are is these are position adjusters. And so I can set, let's say I wanted to put a black hole into the system. So this black hole is modeled after the second smallest black hole ever found. It's got a mass of about 6.3 solar masses. And if I want to place it into the system with an arbitrary velocity that I've given it, the velocity is 110. So 1 in the x direction, 1 in the y direction, and 0 in the z direction in unity units. I can change its x position, its y position, and its z position to any arbitrary value I would like. And then I can click black hole. And so what it does is it spawns in a black hole. You can see it over there in small writing. You can see a black hole there. And if we look at the solar system, we can see how it all starts evolving. So let's go down slightly. We can see how everything has started to evolve. If I'd like to speed up the time step, which is what I would like to do slightly, select a slightly faster time step, and we can see here how the planets have started to gravitate themselves towards a black hole, and the black hole has started slowly moving towards the solar system. And we can see because the orbits are able to move in 3 dimensions, we can see how they start spiraling upwards. They still have their initial velocities, and so they will still orbit the sun, but they will now have an increased velocity in the lateral direction. So if we follow the system going up, it's quite a cool thing to look at, if I'm being honest. Well, we see everything start to accelerate as it gets closer and closer towards the black hole. We saw initially they weren't moving as rapidly, but now if we fly between the planets, we can see everything moving quite fast. And now we can see what's going to happen when they get close to the black hole. Their orbits get completely deflected due to the gravitational field caused by the black hole. I've discussed in my report the accuracies and inaccuracies of this simulation, but it's still quite cool to see. You can see how the sun has been deflected out of its orbit, and now we have some planets orbiting the black hole. So Venus and Mercury now have an orbit of the black hole. And Jupiter may or may not join them, I'm not sure. This always depends on the initial position that we give them, that we give the black hole. No, so it's going to carry on again. Okay, that's fine. But as you can see here, the positions of all the planets have been drastically altered. That line there represents the Earth moving, and we can see now it may start to orbit the sun again as the sun starts to move towards the black hole once again after having its orbit deflected. So if I increase the time step again, we can see that all the objects gravitate towards this black hole. As you can see, these objects coming up again to meet the black hole, which is just a very dense body in a very, very small radius, meaning that objects can get quite close to it, which is the conditions necessary for a black hole. So now you can see what's going to happen again. There you can see the orbit's deflected again. And this will carry on for quite a while. So now this is going to be a demonstration of the solar system collider. And so in the same way, if we spawn in our regular solar system and we let it evolve for some time, in the same manner as we did before, we can change the X position, the Y position, and the Z position sliders to some arbitrary values. And I click the solar system button. What it does is it spawns in another solar system with the sun at these coordinates here as shown on the right hand side. So 429, 727, and 280. And to not bore you too much, although this is a very interesting scenario, I'll increase this time step slightly. And as we can see here, the suns are starting to slowly move towards each other. Even though in reality this process would take thousands of years.
Solar system, and we let it evolve for some time. In the same manner as we did before, we can change the X position, the Y position, and the Z position sliders to some arbitrary values.
The planets are still orbiting, but again their velocities have been increased in the direction towards the second solar system.
So 429,
and we can see how everything is starting to accelerate now as the bodies attract each other. However, most of the mass is concentrated within the sun, and so the planets closest to each independent sun will continue orbiting them.
I'll increase this time.
And this bit, as discussed in my report, is not very realistic, but we can see the conditions of why that is in the report.
Slowly move towards each other.
And yeah, this is the aftermath as planets
process would take thousands of years.
Interact with each other.
But we can see how the planets are still orbiting, but again their velocities have been increased in the direction towards